Greetings to everyone. My name is Purushottam Majumdar.
My name is Amay Dev.
And today we are going to give a talk about what is quantum mechanics. And basically we will try to make you understand that what is quantum mechanics and how it is it can be related to our consciousness and how it can influence to our reality. As you know, in the physical world we live in is made up of atoms, which can be divided into its elementary subatomic particles, that is electrons, protons, and neutrons. So before jumping into the topic, we need to know a bit about quantum mechanics, so that at least you could have a glimpse that what we are going to discuss. So basically, what quantum mechanics actually is. So quantum mechanics is a branch of physics which deals or try to explain that how this universe works in such small scale, even smaller than atoms, that is in the subatomic scale. The behavior of the quantum world is beyond wave. Particles being at different places at once communicate at very fast rate, even faster than light. Now it has been past centuries, and till the foundation of quantum mechanics, and the physicists are still debating about the fact that how they can depict these equations. One of the particularly weird notion of quantum mechanics is that how quantum mechanics and consciousness can relate with each other and how it can influence to our reality. To know that, we have to understand and experiment. Even some of the founders also thought that quantum mechanics and reality were deeply linked at that time. So we need to understand and experiment. Let us say we shoot some balls like metal. Let us say small marbles, and we let those marbles pass these two slits. We'll definitely see two bands of line which will form on the screen. But instead of shooting all those marbles, we'll shoot a stream of electron, and the result was completely different. They don't show two bands of pattern; they show an interference pattern, a pattern of dark bright fringe, just like this. In the year 1801. This experiment was again conducted by Thomas Young, but instead of shooting all those marble and stream of electron, he did this experiment with a monochromatic light. He projected the monochromatic light and he let those monochromatic light pass through this slit, and the result was similar, same interference pattern formed. So, just like this, and the result would be pretty much similar if the wave of water passed through this two slits, and this kind of interference would form on the screen, as you can see from the slide. Now the further slide of my predictions.
In the year 1947, physicists thought that electrons are somehow bouncing off each other and creating the interference pattern, as you saw earlier. So in that year, three physicists, as you can see their name on the screen, they performed an experiment where instead of firing many electrons, single electron was fired repeatedly at a time. So it took more time than the previous experiment, obviously, but it still made an interference pattern like that. And only a wave can make an interference pattern like that. So we suggest that the electrons are now behaving like wave. De Broglie and Schrödinger in 1924 and 1926 gave the equations of the wave associated with the electrons. This equation, this wave is also called meta wave. Actually. To know what is going on, a detector was placed near the two slits. Which would measure, which would detect one of the two slits taken by an electron before hitting the screen. As you can see, this detector is named Which-wave detector. But now, surprisingly, instead of making an interference pattern, the electrons make two band of patterns like that. As you can see, two bands of pattern are formed, not like previous interference pattern, which suggests that the electrons are now behaving like particles, contrary to previous experiment. So, But when the which detector was turned off or removed from this entire setup, the interference pattern would show up. It was as if the electrons knew when we are watching them and when we are not. As you can see, huge wave detector was turned off and video. As soon as the huge wave detector was turned on, the two bands of lines were formed. Now there are some interpretations to this phenomenon. One of the earliest and most widely recognized interpretation is Copenhagen interpretation. It was devised in 1925 by Niels Bohr and Werner Heisenberg. It tells us that the very act of measurement or observation causes an experiment to settle on a particular result, and that it's meaningless to talk about a well-defined objective reality before that measurement is even made. The Copenhagen interpretations explains the result of double-slit experiment by saying that the electron does not travel as particle or as a wave. Instead, it travels as an abstract probability wave, something we call as wave functions. It means that the state of an electron, that is whether it is a particle or wave, is not determined. But as soon as we make the measurement, as you can see, it shows the particle nature. As you can see, when the detector was placed, it shows particle nature. But the Copenhagen interpretation does not say anything about consciousness. It just says that the measurement collapses the wave function of an electron, and when it does, it shows particle nature like that. But what is the measurement after all? Does measurement take place at the instrument that measures it? Does it take place when the instrument is recording its measurement in the memory, or does it take place when a human sees the result and the brain interprets the result, or does it take place somewhere in between the other? This is still debates among scientists, and we still don't know the answer. Another such interpretation is called Newman-Wigner interpretation, which basically postulates that in the long chain of measurement, the collapse occurs at the moment that a conscious, presumably human consciousness, interprets the measurement. In other words, the consciousness of the physicist is making the particle distinct. But this raises all kinds of potential questions about what constitutes consciousness and how is it involved in this process. Can the consciousness of a lizard or a worm also collapse the wave function of a electron? The most fascinating interpretation is many-word interpretation. It was given by Hugo Barrett in 1957. It basically states that as soon as we make the measurement, the wave function collapses in our reality, but the wave function continues in another reality where no measurement is taking place. And it also states that there may be infinite number of worlds where no measurement or defined measurement or measurement could take place. In my view, the Copernican interpretation is most likely correct. A paper published in 2011 by Shani and Denko Nikolic also showed back the Copenhagen interpretation. Their experiment recorded the Huichi information. Huichi information means the information about that which one of the states electron took before hitting the screen. Their experiment measured the Huichi information and recorded it in the state of an atom. Where the physicists are not made where physicists are not made able to the information that whether the collapse occurred or not. But it was, in other words, it was made available to the universe. But this collapse occurred still then. So to sum up, maybe something is watching this collapse, but it does not have to be consciousness. Observant does not have to be conscious. Werner Heisenberg once said, "What we probe is not in nature in itself, but nature exposed to our method of questioning."
Thank you. We'll take questions. Is there any questions?